Yes. All right, thanks. Moving on to our next presentation will be Ari Posner with the Bureau of Reclamation, and he will be discussing the linking the morphodynamics and habitat conditions in the Isleta reach of the Middle Rio Grande.
Well, thank you for those previous presentations. That's really interesting. I think that you're definitely going to hear some common themes in this presentation. I think there's really great overlap. I think we're complementing each other's work in many ways. So I think that's pretty cool. And what I decided to present on was this very specific method that we developed in order to try to combine hydrology and geomorphology. You know, kind of like Aubrey presented, there's a whole lot of work that's done around mapping habitats at different discharges, and then this whole other effort of correlating hydrology, different hydrologic metrics with minnow populations. And so because we're so data limited, we had to derive this method in order to fill in some of the gaps to look at these long-term data sets. Obviously, we have fish data sets going back to '93, and then the Bureau of Reclamation has these ag-deg lines that is something you all have heard many times, and those are collected on decadal intervals, and they estimate the underwater prism with some kind of trapezoid, and so they're very limited in terms of our depth of understanding of what's going on in the channel. One, and two, they're only collected every 10 years, but we have fish data going back annually to '93. So we're trying to bridge those two scales. I think I've said a lot of this. So yeah, that ag-deg data is spatially continuous, which makes it very rare because often we're collecting cross-section data at specific locations, but we don't collect one snapshot at one time over all 200 miles of the river. And this decadal effort is the one time that we actually do that. So these habitat metrics that you all have seen many times now, looking at the different life stages and the requirements for different life stages that have been identified, and then modeling different discharges and trying to figure out exactly how much area of any given length of river fits those qualifications. And these are obviously limited to the data sets that we have, that ag-deg data that I was talking about, and then what we do, and Tetra Tech did an excellent job of this for the core of putting in the most recent cross sections, replacing the ag-deg lines with observed cross sections, and then interpolating back into the ag-deg lines. So there are ways that we continue to update these models. So, but then what we decided to do was translate those kind of histograms of how much data, how much habitat is available at each discharge into a curve. And so now we have a curve, and that curve illustrates how much data, how much habitat's available at different discharges, and the curve actually kind of lends us some insight into the shape of the cross section. And so what we can see is over time, the cross section changing, and therefore the habitat available changes over time as well. This is a location where you have a lot of incisions. So it's a pretty dramatic example where at lower discharges there was once habitat, but now due to all the incision, there's very little habitat until you get into that overbanking flow that's happening much later, or much higher discharge more recently than previously. So, so these habitat curves could be developed and used to estimate both the shape of the channel in that location, but also how much habitat we can expect over the duration of a hydrograph, for example. So we can use this curve to estimate the habitat over a hydrograph, but then, which we did, but then how do we fill in those years in between? We have a 92 set and we have a 2002 set. And so the strategy that we came up with to interpolate between those habitat curves was to use the cumulative sediment mass at the nearest gauge there. And based on that cumulative sediment graph, develop this, this coefficient, and then use that coefficient to interpolate for each year between the two endpoints, the 2002 and 92 in this example. And so what we're able to do is create a new habitat curve for every year, and then run the hydrograph based on that updated curve. So in order to do this, another step that we had to take was to, because we wanted to look at the different life stages of the minnow. And so each of those life stages happen at different times of the year. And so we divided up the hydrograph into these different times of the year that are critical to the minnow life stage. And you can see that at the bottom there. So this is kind of how everything gets combined. You have an interpolated habitat curve that's combined with a hydrograph that's been kind of cut up into these life stages. And then from those, we can get the habitat available for different life stages for any given year. And this is the result of that. So for each year, we have different amounts of habitat available based on the hydrograph for each life stage. Then what we can do is we can compare that to the minnow data, because now we have both of these data sets at that same annual time scale. And these are some bivariate plots that we looked at, and we looked at not only this TIM, this time integrated habitat metric, but then also looked at all of kind of the classic hydrologic metrics, mean daily discharge for the adults versus the juveniles, 28-day high discharge for the larvae, etc. And so there were some interesting relationships there. And then we also did this multilinear regressions, looking at a whole variety of different models. In this case, with respect to the habitat metrics, there were 64 different models tested, and the May-June habitat received 51.7% of the weight, and so was the strongest model of all the 64. And the spring larvae habitat covariate accounted for 15.7% of the deviance with a 95% probability. So, you know, really targeting in on those spring flows. And we did the same thing for the hydrologic metrics. And what you'll see is that this May-June 28-day high, which in many ways is this May-June habitat is kind of a surrogate for, right? These should be telling us approximately the same thing. And it received 55.8 of the weight out of 196 models. And that covariate accounted for 34.1% of the deviance with a 99.9% probability. So what this is telling us is that that the hydrology is still a better metric for predicting minnow populations. So so some of the conclusions that we could come up for this work is basically that it's unclear if in-stream habitat complexity is available at moderate discharges is sufficient for retaining and rearing larval minnow during years with low water. So I think we still don't have an answer about that, and this really wasn't able to tell us anything about that. That findings suggest that maintaining habitat availability through in-stream flows, particularly during low season, is anticipated to produce positive population responses. So that July-September is still quite important. And really the limitations of some of the work was that these habitat metrics didn't fully capture the spatial and temporal variations of the floodplain inundation. And this is something that's been mentioned before about these 1D models. The larval fish habitats were predicted to substantially increase with relatively small increases in discharge. And this is in part a function of those habitat curves and just how sharp that increase can be. And that is also related to these small differences in flows having a notable impact. Because of the many perched locations in the Middle Rio Grande Valley, you have to do some kind of twisting of the models to get them to keep the water in the channel before they spill over the banks. And then you have to do some switching in order to represent the overbanking flow. So this is a real difficulty, and it kind of is the art part of a lot of the 1D modeling. And limited channel data availability that's also been discussed, and the fact that we have a highly variable mobile bed. A little, just finally here, the challenges and next steps that 1D modeling and those assumptions associated with perched channels that I referenced. One of the things that we're doing is we're developing stochastic modeling tools to predict probabilities of various conditions. So that's happening, and we'll soon be able to do that. We're going to be continuing to collect and incorporate that cross-section data to have the most updated models. We'll also be collecting new ag-deg data. Continuing to collect water surface elevation data during flows and areas of interest for model calibration validation. And to monitor change. Aubrey mentioned that as well, and we did do that quite well in 2019 when we had those high flows. And building 1D, 2D hybrid models where the data is available. And so we'll continue to do that. And then also kind of trying to make sure that we're representing the sediment transport, because that is the generator of morphologic change, along with the stochastic modeling we'll be doing for the hydraulics. We're also in the process of building a stochastic tool for sediment transport modeling, and that should be really interesting and give us kind of a better perspective on exactly what's happening out there, or our ability to model it anyway. We're collecting continuous acoustic sediment, suspended sediment at Santa Acacia, which can really improve our modeling. Right now we get daily average or 15-minute results, and having the continuous values is, we can really see those pulses and the rolls of ephemeral channels and whatnot. We're collecting suspended and total load. Bed material samples are collected across the MRG on a triannual basis every 3 years. Continue to update models. The Corps actually collected this high flow dune data to assess bed load, and that's, I think, something we can learn a lot from. We will be learning a lot from in the coming year here. They're still working on that report, I believe. And then our intention to combine these paired sediment data, which we collect at the gauges, with the sediment transport modeling and develop more robust sediment budgets. And that's something that we're kind of hoping to continue to refine. With respect to channel of data availability, we're hoping to get we will be getting MRG wide LiDAR in 2022. Hopefully the water will be low so we can see the channel. It's the 1 year that we don't want a high runoff. And that we'll also be collecting new or generating new ag deglines and continuing to collect our cross sections. And just finally, the fact that we work in a highly variable mobile bed, sand dominated alluvial channel system will continue to vex any kind of specificity or robustness of any particular result of hydraulic modeling, and hence the move toward representing them as probabilistic values. But that's all I have for you today. Thank you.
Great. Thanks, Ari.